In example 3e, let's first check to see if this represents a function. So if we apply the vertical line test here, we are going to just draw various vertical lines and see how many times each vertical line intersects the blue graph. Okay, so if I drew that black vertical line, we hit the curve one time. I'll do another one. Again, the vertical line hits the blue curve one time. You might be wondering what's going on right here. If I draw the vertical line right here through x equals 6, and it passes through that open circle there, remember the open circle is not part of the graph, so you are technically still passing the vertical line test because the green vertical line does not actually intersect the blue graph at all at x equals 6. Okay, so anywhere we draw a vertical line, it will intersect the blue graph in at most one point. So this graph does represent a function. All right, let's determine the domain next. So let me get rid of these vertical lines. So as we've been doing, we know domain represents the x values. We want to write down every single x value that this graph covers. And remember, we do this from left to right. All right, so find the leftmost point on the graph. Okay, so if we look at the leftmost point, that's right here. If you see where my cursor is, I'm going to go ahead and write down the coordinates of this point. This point is located at -6, and the y value is 3 here. Okay, so we're going to go ahead and write down the x coordinate of this point because domain, we're dealing with x values. Okay, so the leftmost point has an x coordinate of -6. Okay, so that's where the graph starts on the x-axis, and then there are no gaps. Okay, and then the rightmost point on the graph is this open circle, and the coordinates of this open circle are 6, 2. Okay, so we are going to write down the x value of that point. Okay, so this blue graph exists between the x values of -6 and +6. Now we need to handle the endpoints. If we go back to the point corresponding to an x value of -6, so this point right here, that is a closed circle, so we want to include that point in the domain. So we're going to put a bracket. And then if we look at the open circle, that's the rightmost point on the graph that corresponds to an x value of +6. This is an open circle, so that point is not actually part of the graph. So we don't want to include 6, so we're going to put an open parentheses there. Okay, so basically this blue graph exists between all real numbers between -6 and +6, including -6, but not including +6. Okay, so these are the x values that the graph exists between. All right, now if we take a look at the range, okay, we're going to write down the y values, and we're going to go from the lowest to highest. You always want to go in these directions. All right, so locate the lowest point on the graph. Okay, here, right here, this is the lowest point on the graph. This point has coordinates -2, -4. Okay, so we need to write down the y value for the lowest point. Okay, the lowest point on the graph has a y value of -4. Okay, now we locate the highest point on the graph right here. This point has coordinates. It has an x value of 0 and a y value of +6. Okay, so again, we need to write down the y value for this point. Okay, so this is telling us that the blue graph exists between y values of -4 and +6. Now we need to handle the endpoints. I'm going to go ahead and erase these red dots that I have at these points. Okay, notice there's no big fat open circle here. Okay, it's just a solid line. This blue graph is made up of these 4 different line segments. Okay, since there's no big fat open circle there, that means all of these points, with the exception of the open circle right here, all of these blue points are part of the graph. Okay, so we are going to include this point -2, -4 is included in the graph, so that means we want to include -4 as part of the range. And likewise, 0, 6, there's no big fat open circle there, so 0, 6 is part of the blue graph, so we will include 6 in the range. All right, so this graph exists between the y values of -4 and +6, including those endpoints -4 and +6. All right, going on to example F. All right, let's go ahead and figure out whether or not this represents a function. So we're just going to draw our vertical lines, okay? And it's pretty easy to see that this particular graph is going to pass the vertical line test, okay? Again, if we drew one of our vertical lines through the open circle right here, that is not a problem because that open circle is not part of the graph, okay? So technically the vertical line does not intersect the blue graph, okay? So no matter where we draw our vertical line, it hits the blue line in at most one point, so this is a function. All right, let's move on to the domain. Okay, we're going to write down the x values covered by this graph, and we're going to work from left to right. Okay, we're going to first locate the leftmost point on the graph. Okay, so that's going to be this open circle that has coordinates -4, +7. And we need to write down the x coordinate of this point. Okay, so that's going to be -4. And then we need to find the rightmost point of this graph. Well, if you look at the endpoint here, there's an arrow that indicates that the graph keeps traveling to the right forever. Okay, so we can never reach the rightmost point. This line, this blue line, is traveling forever in the positive x direction. So it's going to go off to positive infinity. Okay. As far as endpoints go, we know we need a parentheses on infinity. If we go back and look at the point -4, 7, that is an open circle, so we're not actually supposed to include that point in the original graph. So we need to exclude 4 from the domain, so we put a parentheses. Okay. All right, let's take a look at the range. Okay, so range, we're going to look at y values. We need to write down all the y values covered by this graph. We need to work from the lowest point to the highest point. All right, when you look at this graph, it is just a horizontal line segment, or a horizontal ray, I should say. It extends indefinitely in one direction. So basically every point on the line is tied for the lowest and highest point. Okay, so they're kind of all equal. Okay, so you may be wondering, well, what's going on here? Well, let's look at it this way. To determine the range here, it's a little bit tricky. I am just going to label some points on this line. Okay, we already know -4, 7 is the open circle. If you look at this point right here, it has coordinates 0, 7. If I look at this point, it has coordinates 2, 7. This guy has coordinates 6, 7, and so on. Okay, just looking at various points on this line, I'll do one more. This is -2, 7. No matter what point you pick on this blue line, they all have something in common. They all have the same y value. Okay, and remember, range is saying, hey, what y values does this graph cover? Well, every single point on this blue line has a y value of 7. That's telling you there's only one number in the range. Okay, so 7 is the only y value. It's the only output here. Okay, so I'm going to write that down. 7 is the only y value or output that we get here. Okay, so how do we write this down? Well, if you remember back when we did section 3.1 and we talked about listing things, okay, we don't have, an interval to go between. It's not a situation like this. We don't have, all the y values between -4 and +6, including -4 and including 6. We don't have that situation like we did in example E, okay? We just have a single number in the range. So we list it, okay? And remember, the way to list is to use the braces. 7 is the only number or y value that you get here. Okay, another way you can notate this, you can do an interval. You can say the smallest y value is 7 and the biggest y value is 7. And remember, we want to include 7 because it's the output. It's the only output here. So you could write it as an interval from 7 to 7 and include it. Okay, so either of these notations is correct, whether you do the interval from 7 to 7 and use brackets, or you just put 1, 7 and use the curly braces. Okay, either are acceptable. Okay, so that was a bit tricky. All right, moving on to example 3G. All right, we first need to determine, is this a function? Okay, let's draw some vertical lines. Okay, every time we draw a vertical line here, it is going to intersect our blue graph and at most one point. So this particular graph does represent a function. Let's work on domain. So we need to list the x values that this graph covers. We're going to work from left to right. Okay, so we're going to start and find our leftmost point. The leftmost point on this graph is right here, this closed circle. It has coordinates -10, 3. Okay, so since we're doing domain, we need to write down the x value of that point. Okay, and now we need to locate the rightmost point on the graph. Well, this arrow tells us that the line keeps going in this direction forever. So the graph is going to continue indefinitely in the positive x direction. Okay, so we're going to write infinity as the rightmost point. Okay, we know we need a parentheses on infinity. If we go back to -10, because the graph starts at x equals -10 and then it continues rightward forever. If we're looking at this closed circle, that's where the -10 came from. That is a closed circle, so you want to include this point in the graph. Okay, the point is included in the graph, so that means we are going to include -10 in the domain. So we need a bracket, okay, on the -10. Okay, so the domain here is all real numbers, -10 and bigger. Those are the x values that this particular graph covers. Okay, let's lastly look at the range. So we need to write down all the y values that this particular graph covers, and we need to work from the lowest point to the highest point. All right, so I'm going to go ahead and erase this. Okay, so if we look at this little segment right here, okay, all of those points are tied for the lowest point on the graph. And, you know, if we just look at them, I'm going to write down the coordinates here. This particular point is -4, -4. This point is -2, -4. You know, it continues indefinitely. This point would be 2, -4. Okay, so all of those points are considered the lowest point on the graph. If you notice, they all have the same y coordinate. We're doing range. We're writing down y coordinate. They all have the same y value, which is -4. Okay, so all the low points on this graph have a y value of -4. We're going to go up to the highest point, which is -10, 3, and we're going to write down the y coordinate. Okay, so this tells us that this particular blue graph exists between the y values of -4 and +3. We just need to handle the endpoints. Okay, so if we go back and look at this, okay, when we're looking at our low points, this little segment, okay, there's no big fat open circle. Okay, it's a solid line. That means all of those points are included. So we are going to want to include the -4, that particular y value, in our range. And then the high point corresponds to the closed circle, -10, 3. Since it's a closed circle, that point is included in the graph. So we will include 3 in the range. So this particular graph covers all y values between -4 and 3, including -4 and including 3.